Lesson 310. Today, we're going to learn about how to solve equations that involve trigonometric equations or inequalities. So solving, I should say, equations or inequalities that involve trigonometric functions. That's what we're going to look at today. So a whole bunch of solving. I could say it this way. What we're doing is we're taking what you've learned in Algebra 1, and we're going to add that together with what you learned in Algebra 2. And what we're going to add with that is the trig you've learned here from pre-calculus. We're adding those all together, and what it's going to be is it's going to be awesome. Not into the humor? Okay. Well, that's what we're doing today. We're going to take your Algebra 1, Algebra 2 skills, and we're going to add in some trigonometry. And that's what we're going to basically do all day long. So with that, I'm going to jump into solving. This first slide, if you want to read it later on, it's just telling you that if you're going to focus on using the calculator, you might run into a problem. That's because trigonometry with inverses do not show all the possible answers. And so that's just kind of what this is walking through. I'm going to teach you as I go. Again, that's just for later on if you want to read that. So let's first start. The easiest way, the absolute easiest way to solve any equation that involves trigonometric functions is by graphing. The unfortunate thing is you can't use a calculator on all your tests. Equation 1, though, is to show you how, if you were going to solve an equation, a trigonometric equation by graphing, how you would do so. It says here, consider this equation, sine x equals 1/2 on this interval. Now, it says, notice the x-coordinates where the graph of y equals sine x intersects the line y equals 1/2 are the solutions to the equation. Now, it just jumped ahead and didn't tell you what to do here. Let me explain. If you're going to graph, here's how you get solutions by graphing. Solutions by graphing. You want to write this down here. Solutions by graphing. What you're going to do is you're going to, step 1, you will graph y equals the left side of the equation. And then you will, step 2, graph y equals the right side of the equation. And then 3, you will, the solutions are the x-intercepts of the intersections. Pull that up. Solutions are x values at the intersections of the graph. Okay, so that's what they do here in this problem. So as you write that down, just quickly glance at the intersections here. How many times, this is the line y equals 1/2. The wave is the graph of y equals sine x. I want you to take a look while you copy down that. How many times do these graphs intersect one another? There's 1, 2, 3, 4, 5. Y'all seen 5 intersections? I am. So on part A, it says, can you name the 5 solutions shown? The way you would do it is you would list out the x values. You'd say, well, x equals, and you would label them all. Now, just to be clear here, this is pi over 2. And if I want to know what is each tick mark worth, what I would do is pi over 2 comes on the third tick mark. So that means the first tick mark would be whatever pi divided by 2 divided by 3 is. Now, why is it pi divided by 2 divided by 3? Because there's 3 marks to get to pi over 2. What is pi divided by 2 divided by 3? Not divided by 5. You're dividing, which works like multiplication, so you're not adding them. What's pi divided by 2 divided by 3? Pi over 6. Another way to check this is pi is on the 6th mark. 1, 2, 3, 4, 5, 6. So if pi is on the 6th tick mark, that means each tick mark was a 1/6 of 1 pi, which means it's pi over 6. So just so you know, that's what we're counting by. So I'm going to start over on this answer. We'll go left to right. This answer is at negative 1, 2, 3, 4, 5, 6, 7. Negative 7 pi. Whoops. Negative 7 pi over 6 is our first solution. Negative 7 pi over 6. That's our first solution. The second intersection, as I go left to right, occurred here at pi over 6. That was our second solution. Let's find our third. If that's 1, 2, 3, 4, 5 pi over 6, I'm getting another solution. At 5 pi over 6. That's 6, 7, 8, 9, 10, 11, 12, 13 pi over 6. 13 pi's over 6 is our fourth solution. And y'all tell me what's the very last one?
17 pi over 6.
Now, notice that our answers typically are going to have the same denominator all the way through, the same radian denominator. This is what's really nice about radians. A lot of times, once you find one, you can kind of quickly estimate the other solutions. Now, if you were working in degrees, which AP Calculus will not, but in the real world, we frequently work in degrees. It's a little bit harder to just pick out what's going to be the recurring answers because you're not working off the same denominator. Here, it was very predictable. From negative 7 pi to 1 pi, that was an increase of 8 pi. Then I went pi to 5 pi. That was an increase of 4. Well, then I increased by 5 again, and then by 4. And you can see the pattern. So the next one, since I just increased by 4, the next one would be increase the numerator by 8. It would be 25 pi over 6. And then I would increase by 4. It would be the same pattern over and over and over. You could estimate as many answers as you need. So now it says, how do we represent all the solutions of the shown? Well, here's what I would do, is I would write out just one period's worth of answers. So what do I mean by a period? What's a period mean? One cycle. I would write out like one cycle of answers. So I'm going to take these two right here. I would write those two out. And so I'm going to say x equals pi over 6. And I would write x equals 5 pi over 6. And then what you do is you would add a period with the letter N or the letter K. Just pick whichever letter you want to use. Now, what's our period on this one? If I started here at the origin, how long does it take to complete one whole wave? 2 pi. So 1 period is 2 pi on the sine function. Do y'all remember what cosine's period is?
Pi?
Nope. It's 2 pi as well. Do you remember what tangent's period is? It's 1 pi. Yep. So what you do is you take that, and so you're going to add 1 period, and you're going to throw on the letter either N or K. Okay, I'll put a letter N. This time you can use N or K. What that means, once I do a comma here, that N is an integer. What that means is you can continue adding on a period after another period after another period as many times as you want, as long as you're adding on whole periods, not half periods or 3/4 of a period. But N is a integer, meaning a whole number, positive or negative. You could keep adding those on, and that would give you all the equations. This would be all the possible solutions you could ever have. If you went to all reals on the domain, this would find every last single intersection right there. That's what that represents. Okay, so make sure you know the pieces. Where did the pi over 6 and 5 pi over 6? Why did I only choose those two and no others? I took 1 cycle's worth of answers. I took 1 cycle. Why the 2 pi here? That's the period. Why n? That means I could do it as many times as I wanted to, as long as I was adding a full 2 pi. I could do it once, I could do it twice, I could do it 3 times, 4 times, so on. That's how you write that out. Okay? Now that's the easiest way, we're not doing much work to get solutions. That's the last time till about example 5 that we're going to get our answers from the calculator. I want to make sure you understand the algebra, because that's the majority of your test. 3/4 of your AP exam is going to be no calculator. We got to make sure we can do this without a calculator. So how do we do that? Let's go on to example 2. And this is where algebra 1 meets algebra 2, and you combine it with your unit circle knowledge from trigonometry, and it's going to be awesome. Wasn't any funnier the second time. Should have just quit the joke after that one. All right, let's start through. What would you do if you walked into algebra class and you were trying to solve for this letter X right there? What would you do first? You would subtract 1. This is called, if you remember, isolating the variable. We identified the variable as X. I want to isolate it. I want to get it all by itself. So we subtract 1. All right, I'm going to start just bouncing around to keep you active. Ruby, what would you do secondly? Divide by 2. Perfect. We would divide by 2. Now, many of you are going to be able to get a solution from this point here. Cosine is equal to -1/2, but I'm going to make the math perfect here. Technically, x is not isolated. Actually, no, I'm going to show you different. Here's how I'm going to do it. Let's go over it. On a unit circle, cosine represents what type of value, an x or a y? An x. Okay, on the unit circle, I'm going to draw 4 points just this first time. I won't draw it every time, but this first time, just to remind you, on a unit circle, this point would represent 1, 0, because a unit circle has a r value of 1, a radius of 1. This point would be 0, 1. This point would be -1, 0. And finally, this point would be 0, -1. And I could include the pi's here. That's 0, pi over 2, pi, 3 pi over 2. And finally, if I went all the way around the circle, we'd be at 2 pi. Okay, you just told me, what does cosine represent the unit circle? X. We're going to need an x value of -1/2. So it's going to be the value that cuts through about right there. Why right there? Because that's -1. This is the origin. Should have put the origin there. That point right there would be 0, 0. So we're cutting through the point there. There are going to be 2 possible solutions this time. I'm going to have a solution on this part of the circle and this part of the circle. That's what we're going to solve here with. That's what we're about to solve. What is that radian measure? What is that radian measure? That's how we're going to get our solutions. We're going to need to know, what are these 2 answers? Okay, so now picking back up over here. Doing the algebra, to isolate this x, we would do a cosine inverse. X would equal cosine inverse of -pi over 2. Well, as we learned last class, cosine inverse is only going to give us one answer, and it would be this answer right there. So I'll show you how to get the other one. Show me your hand trick first. Look at your left hand. This says cosine inverse. So do I look at the palm of my hand, or do I look at the back side of my hand?
But
The back. You eat pie with the palm of your hand. No one eats off the back of their hand. We all go home and eat off. No, I mean, whatever. Okay, you're looking at the back of your hand. And we needed a cosine with one finger. It's 1 comes from square root of 1. So show me one cosine finger. Which one do you bend to have just one cosine finger? Is it your pinky or your index? Which one is it?
pinky, ring.
I said pinky. I didn't mean to say pinky. I meant to say ring finger or index finger. It's index. That would give you one cosine finger. Now flip your hand over. Now the answer is going to be a term of pi. How many pi's do you get when you bend that ring finger? Pi over 3. Now this isn't complete yet. To be this answer here, that's the second quadrant. I have to be greater than pi over 2, but less than 1 whole pi. The way to think about it is it's just smaller than 1 whole pi. What numerator would be a number smaller than 3? 2. If you type this in the calculator, it would give you the answer 2 pi over 3. If you had a calculator that gave you good, solid answers like that, mine would be crazy decimals. That's going to be one answer, but we're actually going to have 2 answers because this problem did not originate as an inverse. It originated as a normal cosine. So we're going to give the other answer as well. What value would this be here? What pi over 3 would this be? I'll give you a hint. It's more than 1 whole pi.
So 4 pi.
That one would be just 1 bigger than the denominator, so it'd be 4 pi over 3. So write 4 pi over 3 for this location. That is 4 pi over 3. Now that would not come out of the calculator. So I would have these 2 solutions. I would have 2 pi over 3 and 4 pi over 3. Now look up at the top. It says give general solutions. You know what that means? That means you give them all. So I would need to add something on here. What is the period for cosine? 2 pi. So put plus 2 pi with an n. Plus 2 pi with an n, comma, n e z. What does z mean again? That is an integer. Give me an example of something that is an integer. I heard 2. 2 is an integer. Give me a number that's not an integer. 1/2, 0.5. Very good. What about -1? Would -1 be an integer? Yes.
We have to add pi for 2n.
No. For sine and cosine, we almost always will until we start seeing transformations. Tangent, we won't. Tangent has a different period. What's tangent's period? Pi. So that time it'll be just pi n. Good question. All right, let's go to the next one. Which, hey, here it is. Tangent. What would we do first on tangent? Yuri says add 5. Y'all agree with her? Let's add 5. So let's see here. I got 5. What world? Let's try this again. I got 5 tangent equals 5. All right, now what? We're going to divide by 5. So when we divide by 5, we get that tangent x equals 1. Now, many of you will probably just go ahead and get your answer from here, but just to be mathematically accurate, I still don't have x isolated. So how would I isolate that x? What's the opposite of a tangent? Inverse. That tangent is not multiplying, it's a function. We got to do an inverse function, an inverse tangent. So it'll be tangent inverse of 1. That's what we're going to look for. Now, I'm going to come back up to this. Sine that we dealt with, oh, we didn't deal with sine yet the first time, I'm sorry. We dealt with cosine. Cosine was on the unit circle x's. Sine is y's. What is tangent like on the unit circle? Slope. This means we're going to have a slope of up 1 over 1, up 1 over 1. So here I'm going to put a line on the graph. Tangent is a line with a slope up 1 over 1, which means it'll be the line y equals x, just like this. These would be our answers. A slope up 1 over 1. Now, what would this, so just go ahead and add that on there. Up 1 over 1, that would be our solution, a slope of 1. You know what, I should write that in there. A slope of equaling 1. The tangent is the slope is 1. Okay, now, go to your hand trick. I'm now picking up on what I have written here in black, the tangent inverse. If you're doing tangent inverse, which side of the hand should you look at? The back. Look at the back side of your hand, and we need tangent to be equal to 1. That means whatever finger we bend, we need just as many y's as we need x's, because tangent is y over x.
Middle.
Which finger do you bend to get the same amount of y's as x's? Middle finger. So flip your hand back over. What is the middle finger? When you flip it back over, that is pi over 4. Okay, pi over 4 is this answer right there. Now, this third quadrant would generate a different pi over 4. What pi over 4 would go in here? Let's think about it. This is 1 pi. So if you're just past 1 pi, you're 5 pi over 4. That's right. So the two solutions that you would think through would be pi over 4 plus, okay, now what's the period of tangent? It's not 2 pi. Pi. And so you do pi n. The other solution set that we would like to write would be 5 pi over 4 plus pi n. But you don't actually need to write the second one. Without me telling you, can anyone think of why would I not need to write the second solution set? Why could I be done after just writing the first without even writing down the second?
Because it's in the third.
So why does it matter if it's in the third?
That first one will eventually multiply pi over 4.
This one will get there because let's say n is 1. Let's add 1 whole pi. If you had pi over 4 and you added just 1 pi, what is pi over 4 plus 1 pi, meaning pi over 4 plus 4 pi over 4? 5 pi over 4. Or think of it this way. How many radians are on this straight line here? What does that say right there? Pi. That means if I took this and add a pi, I should get 5 pi over 4. This is not necessary, already included. It's included above. With tangent, you typically don't have to lift both of them out if you're listing the general answers, because the first one will find the second one as well, because they're going to be 1 pi apart as it is, which is the period. So tangent is a little bit easier. You only have to list one. That would be our solution set there. Okay, so it's time to see if this is making any sense to you. Actually, I say that. No, I'm wrong. I'm wrong. Sorry. I got a part C. My bad. Let's work out part C, and then I'm going to let you try one. All right, part C. Let's take a look over here. What should we do first? Let's combine some like terms. I have a -7 and a -5. I see my cosines are bigger over here, and I like dealing with positive cosines. So since I'm subtracting the cosines to the left, I'm going to add the 7 to the right. And I want to show you why, just to make this look cleaner. If I subtract the cosines to the left, what is 18 cosines minus 14 cosines?
4 cosine.
4 cosines. If we do it this way, now what I'm going to do is add the 7 to the right. Like this. So I should have 4 cosines equals -5 plus 7 is 2.
3.
So now we will divide by 4. We're almost to our solution. This is the part where I would typically go to the unit circle. So I'll just write it right here. So we have cosine x equals 2/4 can reduce to become 1/2. I'm going to pause just for a moment and go to my unit circle. Cosine on the unit circle, would I think of x's or y's? X. I need to have an x of 1/2. That's going to be on the right side halfway over. I'm going to do a dashed line to represent where my two solutions should be found. My two solutions should be found when x is 1/2. So the intersection of the circle and those dotted lines, that's where my two solutions are going to come from. That's where I'd have an x of 1/2. It's going to come from there and there. Those are going to be my two solutions at those two locations. Okay, let's come back. To mathematically make my work perfect, I need to isolate this x. How do I isolate that x? Inverse. So x equals cosine inverse of 1/2. So take your hand, flip it over, because it's an inverse. We're looking at the back of our hand. We need one cosine finger. So which finger do I bend? Index. Bend your index, flip it back over to the palm side. What pi is that? That's a pi over 3. So that means the calculator would only show you, because of the restriction on the inverse, it would only show you pi over 3. But because this was original cosine, we're not restricting it to it. We would include this one. What answer is that? It's almost 2 pi. There's your hint. It's almost 2 pi. So take your denominator of 3. If you multiplied it by 2, you get 6. It's not quite 6 yet, so it must be a 5. It's 5 pi over 3. So our two general solutions, cosine's different now than tangent. They're not straight across, and the period's not 1 pi. I need to include both of these. My two general solutions would be x equals pi over 3 plus, what's the period for cosine? 2 pi, and then put the letter in. My other answer that I would need is 5 pi over 3 plus, again, what's the period for cosine? 2 pi, throw in the letter n. This is anytime n is an integer, we have another solution. That would be your solution set there. Now that's what they call a general solution set. That means it'll find all of them. Not just on the first cycle, but any cycle you want. All right, with all that, I'm going to let you get started on your DOL. All right, now let's take a look at example 3. Now, example 3, we're going to be doing the same thing, but what do we do if it's not a hand trick value? That's the only thing that's going to be different on example 3. So let's go through Let's do our algebra first. What would you do first here? We would add 5. So if I added 5 to both sides, I get that tangent x equals what? 5. Now, since I have tangent, the function tangent isolated, remind me, on a unit circle approach, is tangent the y's, the x's, or the slope? So we need a line that has a slope of approximately 5. So go ahead and put a slope like this. I'm going to guess that's approximately 5. Remember, 5 would mean up 5 over 1. I go ahead and write that on my line. I'm going to write it and then twist it. Slope equals 5. Since I have a smart board, I'll use it. There we go. The slope equals 5. So these are my two answers here. It would look like that. Now, where are those two answers? We don't know. We got to use a calculator. Oh, I need to write one more step down. I haven't actually isolated the x. How do I get x by itself? Tangent inverse. And that's what we're going to type in the calculator. Inverse tangent of 5. So let's go over to our calculator. Make sure when you click your calculator here. Mine's going a little slow. Let's wake it up. Make sure you're in radian mode. If you're not, press home screen 2 menu C. Home screen 2 menu C. Home screen 2 menu C. And then you'll choose OK on yours. And it'll clear it and get you into radians. So just make sure you're in radians. So here we go. I'm going to go to calculator. Tangent inverse is you press the trig button. There's tangent inverse of 5. And it's going to give you one answer. Now, so I don't have to go back and forth. I'm going to tell you how to find the second answer. Well, I already told you. What's the period of tangent?
2 pi.
Is it 2 pi or 1 pi?
Pi.
Well, the next answer we're going to see, because calculator will only give you one because of its restriction. It'll only give you one answer. The way you'll get the other one with tangents always really easy. You just add a pi to it. So I want to press the pi button, and I will add my answer to it. So I'm going to add this. I'm going to add what I typed in a second ago. That's going to be my second answer. Now, I'm going to explain this to you in the picture, but that's what I did. I typed in tangent inverse of 5, got the first. Pi plus tangent inverse 5 to get the second answer. So let me go back now over here, and we're going to write out the values. I want to remind you, what is a radian anyways? That number that's coming out of the decimal, the calculator, that's telling you as a percentage of the radius, that is 1.37 radiuses. That length right here to this point, if you went around the circumference of the circle, that right there is 1.73. What are we supposed to round to? Hundredths? What's that? How many decimal places is that?
3.
3. That's 1.37 radiuses along the circumference. That's what that is. Do y'all remember that? That's what radians meant? We went 1.37 radiuses, and we called that a radian. Okay, now this question, this answer set, I just typed in the calculator. Let me explain it now. If I went halfway around the circle, how many radiuses does it take to get halfway around the circle? Pi. It takes pi. Well, this answer choice, or this answer value, is exactly 1.37 past this x-axis. So it would be pi plus another 1.37. Does that make sense? So this one right here would be pi plus another 1.37. That's how I get there. And we get this answer 5.51. No, I got dyslexic. 4.51. That's the other solution. Now for tangent though, you don't actually have to write out both of those. I should have wrote this out 1.37. With tangent, remember that you only have to write out one general solution. I'll do it right here, 1.37. So with tangent, because its period is 1 pi, you only have to write out the first answer. So we're going to say 1.37 plus, what's the period of tangent? Pi, and what letter do we throw in? N, comma, N, E with that double looking Z thing. That would be my solution set for answer choice A. There's my solution set right there. That is all the answers. Okay, let's try this again. Let's reload and do it one more time. They're not all as easy as tangent. I think tangent's the easiest because one answer gets you all of them. Let's do part B. What would I do on part B to isolate the cosine?
Divide by 5.
We're going to divide by 5. And so cosine x equals 3/5. Now, I'm going to pause just for a second. In terms of the unit circle, cosine refers to which variable?
X.
X. So I need to go 3/5 is like 0.6. I'm somewhere out here. My two solutions to generate my solution set are going to come on the intersection of the unit circle and an x value of 3/5. So I'm going to go ahead and draw my arrows. Because it's cosine, I have sideways looking V. Tangent always looks like a line. Sine and cosine will look like a V, but the cosines are always sideways V's. Like that. So those are going to be my two solution sets. Now let's come back over here. For the calculator's sake, how do I get x all the way isolated?
Cosine inverse.
Inverse, cosine inverse. So cosine inverse of 3/5. That's what we're going to type in the calculator here. So trig cosine inverse come on now. Cosine inverse of 3/5. What answer are y'all getting when you type that in?
0.9.
You don't have a calculator. All right, there's one answer. Now I want you to think about the second answer without me telling you. This second answer right here. How can I get that answer?
Minus.
If this was, what was it, 0.97? Is that what it was? If this is 0.97 up, this is 0.97 down, which you can list it that way. You could list it that way. So we could just list it as negative. So for that reason, let me take a picture of this so I can place it in here in a second. We could do it that way, or the other way you could do it is you could subtract from 2 pi. I'll go ahead and type that in just in case you want that. But you could list it as a negative. It's probably the easiest way to do it, is I could now just subtract that inverse right there as well. Those could be my answers. Okay, now let me just take that. And now let's write in our answers here. I'm sorry. Let me get this where you can see them all. Okay, so our first answer here. This one was what, 0.97? Oh, 0.93. Thank you for correcting me. And this value, we could list it as negative 0.93. It's probably the easiest way. Let's list it like that. And which means for our solution set, you do need to write both of them. For sine and cosine, you need to write them both out. I'm going to say 0.93. And then what's a period on a cosine? 2 pi, and throw in the letter n. The other solution will be negative 0.93. Again, you could substitute that with 5.36 if you preferred. 2 pi n. That would work for your other solution set. Oh, I forgot to write one thing as part of my answer. What would I need? I need to tell what n is.
And is all reals.
That's right. Let's see if mine. Not all reals. It's a integer. Yeah, there you go. NEZ. That's what I need to include in there. All right. Let's go on to example 4. Now, here's what's going to be different on example 4 and following. I've shown you today general solutions. That means where I added the 2 pi n or the pi n. From here on out, we're not going to do that anymore. Now we're going to limit our domain. And so we're only going to find specific answers from here on out. Okay? So that'll save a step of time. But let's see how this works. Okay, this first one here. We're increasing the difficulty of our equations as we go. It says solve for 4 sine squared minus 1 equals 0. All right, let's walk through. What do you think we should do first?
Plus one.
Let's add 1 to both sides. So we have 4 sine squared x equals 1. Now what?
Divide by four.
We're going to divide by 4. So sine squared x equals 1/4. Now, before I can go to the unit circle, I still need to get rid of the squared. I need to isolate the trig function, which we haven't done yet. What is the opposite of a squared? A square root. So here's what's weird though, is oftentimes with trig, as the problems get more complex as we move on, they're going to give you context clues whether we should be dealing with a positive or a negative. But technically, if they don't tell us the squared value, since it's squared, we could have a negative answer, we could have a positive answer, because what happens when you square a negative? It turns positive. So both will be true. Both a negative and a positive of this will be true. The only way to account for that is to do a plus or minus. So I'm going to have sine x equals the positive or the negative, and I'm going to reduce this. What's the square root of 1? 1. And what's the square root of 4? 2. So we have possible solutions. Because this is squared, a negative would work, because a negative 1/2 times a negative 1/2 gives me a positive 1/4. So also with the positive, a positive times a positive is still positive. So I'm going to have to find the negative and the positive. So go over to the unit circle. As far as sine is concerned, is sine on a unit circle the x value or the y value? The y. I need a y of positive 1/2, and I'm going to need a y of negative 1/2. Let's go ahead and add in those lines to represent where our solutions will be. I'm going to have solutions here. I use the same line I've been using today. I'm going to have a solution set here, the intersection of those spots, and here. So my answer choices will be here, here, there, and there. I'm going to have 4 solutions this time. Okay, for the calculator, if you're going to use the calculator, how do you isolate this x?
The top, bottom part.
You're going to do an inverse sine. That's how we do it in the calculator. Now, we don't need to on this one. I would have to do it once as a positive and once as a negative. I'm just going to do it as a positive right now. So let's go look at our hand. Take a look at the back of your hand. We have a solution for this on here. If you were taking sine inverse of 1/2, which finger would you bend to give you one y finger?
Middle ring.
I heard a lot of indexes as well as pinkies. Which one gives me one y? Did I hear pink? Did I say pinky? I meant to say ring. Ring or index? Which one? We need to do the ring finger. That gives me one y. Ring finger. Now flip your hand back over. What pi is that? Pi over 6. Now that's what the value you'd get from a calculator, but the calculator is restricted. And as I was just saying, we have 4 potential solutions. So from here, I'm just going to use knowledge of that this is 0, this is 1 whole pi, and this is 2 whole pi's to find the others. I'm not going to go back to doing the math that way. What would represent this value here? How many radiuses would it take to get to this intersection here? I hear 3 pi over 6. It's just a lot smaller than 1 whole pi. 3 pi over 6 would actually be half of a pi. It'll be 5 pi over 6. That's one answer. What's this one if it's just more than 1 whole pi? 7 pi over 6. And finally, if you're almost 2 pi's, that means you almost double your denominator. It'll be 11 pi over 6. Those are our 4 solutions. Now this says only on this interval. Because we're only on this interval, we're not going to list them. We're not going to do the plus 2k pi or anything like that. 2 pi n, I mean. What we're going to do is just write out the answer choice one time. And this is the way your delta math will be. You'll just write out x equals pi over 6 as the answer. Then you'll click the button that says add a solution. And then you would say x equals 5 pi over 6. and you hit the button that says add a solution, and then you would do 7 pi over 6. And you hit add a solution, and you do x equals 11 pi over 6. On delta math, you don't type them in with commas, but you type them in, you keep hitting that button that says add another solution, and you just keep adding them in until you get all 4. So one more time, the reason I'm not doing the plus 2k n, 2 pi n, I'm sorry, 2 pi n, is because this says only list answers between 0, including 0, and 2 pi, not including 2 pi. So any answer between 0 and 2 pi. And so it's only those 4. We're not doing the infinite amount. All right, let's roll it up. Try B. B is a little different. B, I cannot combine these cosines. I have 2 different cosines to work with. So what I taught you earlier in the year, this is called a trinomial. With a trinomial, you get everything to one side, and we're going to do X method. So I'm going to subtract 2 from both sides. So 6 cosine squared x minus cosine x minus 2 equals 0. That's 6 refers to our A. -1 is going to be our B. C is -2. First semester, if you remember, you draw an X. We're going to multiply A times C and put B on the bottom. So 6 times -2. -12. Very good. B is -1. Now, before anybody just yells out the answer, as you finish writing this up, I'm going to walk through the factors of 12. What you're trying to think of are 1 and 12, 2 and 6, 3 and 4. Those are the only factors of 12. 1 and 6, 1 and 12, 2 and 6, 3 and 4. You want to know which of those can combine to somehow give you a -1. You'll pick the numbers and then figure out the negatives. Which ones are 1 apart? 1 and 12, 2 and 6, or 3 and 4? It's 3 and 4. It's got to be 3 and 4. Those are my 2 numbers. It's 3 and 4. Now I need it to be a -1.
-4.
It's a -4. I agree with you. A -4 would work. 3 minus 4 is a -1. So once you do that, what you do is you split the A term. And we could simplify here, but I'm going to do it. You split the A term right here. Oops, I meant to change color so it stands out. We're going to split the A term's power. And so I'm going to write this in parentheses as 6x plus 3. I'm going to run out of space right there. Let me write it right here. 6x plus 3 times 6x minus 4. And in a moment, it'll be equal to 0. I forgot something. Darn it. Hopefully you're not too far. Hopefully you're a little behind me. I forgot the word cosine. You need to put the word cosine in front of x. Let me try one more time. Here we go. 6 cosines plus 3 times 6 cosines. Got it again. Minus 4. That's going to equal 0. Now, truthfully, this A was a 6. And right now, if I were to multiply this out, I would have the A term of 36 cosine squared. So we should simplify, but when you solve, it doesn't actually matter. But just to be technically accurate, what we would do is simplify. What can the first factor be simplified by? 3 can go into both of those. And what can go into this back factor? And so technically speaking, it should actually be 2 cosine x plus 1 times 3 cosine x minus 2 equals 0. Now, if we all remember our algebra 2, what you learned in algebra 2 is if you get here where you are multiplying and you have a product of 0, you can do what's called zero product property. Zero product property. It says this, product property. It says this, the only way in the entire universe to ever multiply and get a product of 0 is that you have to be multiplying by 0. And so algebra 2 teaches you, you can break down this equation at this point and say, okay, 2 cosine x plus 1 has to equal 0, or 3 cosine x minus 2 has to equal 0. Otherwise, this is an impossible problem. So one of those two has to be the case. This has to be a 0 or this has to be a 0. We'll solve each one individually to find the times where we could have 0. So let's start on this first factor. What could I do on this one?
Sure.
We're going to subtract 1. So 2 cosine x equals -1. And
Divide by 2.
divide by 2. Now this will get us on the unit circle finally for the first time. Cosine x has to be equal to -1/2. So cosine on the unit circle is what variable? X. So go to where your x would be 1/2, and I'm going to add on that line, this intersecting line to show us where those answers are going to come from. And we'll solve that in a moment. We'll just do all of our solving all at once. I'll write the next step on there though. That we would type in, or what we would, if you were using a calculator, you do cosine inverse of -1/2. That's what you type in calculator. Now I'm going to come over to this other one, because we're going to do hand trick on that anyways. Now I'm going to come over to this one. We'll solve it. What would you do first if you were solving this second part of the zero product property? We'd add 2 to both sides. After adding 2, we would divide by 3. And so cosine x equals 2/3. Okay, again, cosine is what variable?
X.
X. So you go about 2/3 of the way. I don't know, maybe somewhere in there. And add in your 2 possible solutions for this one. For the sake of the calculator, and we'll need to know the calculator values, I'm going to have cosine inverse of 2/3. Okay. Let me add these in, and we're going to go to the calculator and get our values. Or we can do hand trick first. We'll do a hand trick for the first one. The second one, we'll need a calculator. Okay, hand trick for cosine inverse. Look at the back of your hand. You need 1 cosine finger. Which finger? What do we bend? Index. Bend your index. Flip your hand over. What do you get there? That is a pi over 3. I agree with you. That is a pi over 3. But it needs to be negative, which means the calculator would actually not say negative. To be negative, it would put it in this second quadrant right here. It's this answer. That's the pi over 3. That's not 1 pi over 3. How many pi's over 3 is that? 2 pi over 3. That's what the calculator would say. What would this one be? Again, this is a pi right there, 0 and 2 pi. What would this one be if it's a little bit more than? It'll be 4 pi over 3. So this would, I wrote pi over 3. I need to change this to 2 pi over 3 and 4 pi over 3. That would be my solutions there. Now on this one, I need to go to the calculator. So I'm going to go to the calculator, and we're going to type in. Let me delete this so we're not all in a second when I, what in the world? Well, my stuff's not cooperating with me here. All right, so trig inverse, cosine, was it 2/3? I forget. 2/3. All right, there's one value. Now, we could list it as a negative, but we have a restriction here. Do you see how the answer was supposed to, I can barely see it here. It's supposed to be between 0 and 2 pi.
Mhm.
So my other solution, using the negative won't work. So the negative is taking away from a full circle. What's a full circle? 2 pi. I could get my other answer by saying it's 2 pi minus this amount. That's the way to list it as a positive. So those are the 2 radians amounts right there and there that I'll be using on this. All right, let me close this back off. All right, so let's write down those values. So this is 0.5 0.84. And this last one is 5.44. So 0.84 and 5.44. Those would be the two solutions there. Okay, now let's take a look at example for C. So now let's continue solving what we have. 3 tangent squared minus 1 equals 0. And so here we would need to do some opposites. So let's add 1 to both sides. And so I now have 3 tangent squared x equals positive 1. We would divide by 3. And I divide by 3. I'm left with tangent squared x equals 1/3. Okay, and so from here to isolate this tangent, we now would take a square root. Now remember, whenever we take a square root, it's not originally there, it needs to come with a plus or minus. So that would square that, cancel that out. And so now I have tangent x equals the positive or the negative, and I'm going to reduce this to 1 divided by square root 3. Now I'm not going to rationalize the denominator because this will be helpful for me. But tangent, remember, that's going to be like slope. Our slope is going to have a positive and a negative 1 over square root 3, which this number is less than 1 because square root of 3 is 1.73 roughly. So this number is going to be smaller than 1. It's a little bit bigger than that half. Excuse me, a little bit bigger than a half. So this slope is going to go up 1 over 2 approximately. So it's going to be something like this. If I mark it through, that would be the positive slope, and I'll have one very similar but negative coming through there as well. And so using our hand trick to isolate the x here, I would say I would take the tangent inverse of both the positive and the negative 1 over square root 3. So if I'm looking at the back of my hand, I need 1 y and 3 x's. So I'm bending my ring finger. So my answer is going to be whenever I have a ring finger, which that is when I bend my hand over, I'm looking at the pi side now, it would be a pi over 6. A 5 pi over 6, because this is almost 1 pi. And finally, a little bit more than 1 pi would be 7 pi over 6. And this answer would leave us with 11 pi over 6. So those would be my answers on this problem. Pi over 6, 5 pi over 6, 7 pi over 6, and finally 11 pi over 6. Those would be our answers for part C. All right, I'm going to roll through this one more time here for example 4. Now let's look at solving this problem. Now, as I look at it, I cannot just combine these like terms by subtracting 2 tangents. So what I am going to do though, I am going to subtract the 2 tangents, but unfortunately it will not combine over here. So let's see what happens. This cancels out, and so what I have is a sine squared x times a tangent x minus 2 tangent x, all that equals 0. And so what we do here in algebra is I can't quite solve this, but I can't combine those terms. But what I can do is say, oh, I have a GCF. Both the front term and the back term share a tangent x. So what I'm going to do is I'm going to divide out that tangent x. So I'll do a GCF here, greatest common factor. I'm going to divide out the tangent x. This is the opposite of GCF. And so I'm left with a sine squared x. When I take that out, minus 2 equals 0. Like that. So now I have what we would call a zero product property. A zero product property, algebra 2, tells you if you are multiplying, there's only one way to multiply and get a product of 0, and that is to multiply by 0. And so I can solve each one individually now. I could say tangent x equals 0, or sine squared x minus 2 would equal 0. Now this one's easy. To have a tangent of 0, I need to have a y of 0. So if you flip your hands upside down here, I do an inverse here. And so if we're looking at the back of our hand, I need 0 y's, which means I'm bending my pinky. And so the answer would be 0. So we have a tangent of 0 here at 0. 2 pi could also be an answer, but we're going to limit it between 0 and 2 pi. We won't include 2 pi. So we'd have an answer at 0. And I'd also have the other place we'd have a pinky is at 1 pi. And so this value would be 0 and then 1 pi. Those are 2 answers. Now over here, these aren't going to be any answers at all, because when I add 2, what we're going to find out here in a second is I'm going to be taking the sine squared x of 2. When I take the square root of both sides, we need to have a plus or minus here. It'll be the sine x of plus or minus square root 2. That number is too big when I go to do a inverse, sine inverse, and actually I shouldn't say x equals. I just wrote down sine inverse, positive and negative square root 2 does not exist, because it's outside the restricted domain. For sine inverse, the domains be all values between -1 and 1. So this does not exist. There is no other answers. These should be my only 2 answers on this particular problem. And we could go graph this just to check it out. So I'm going over to graph here, and I'm going to graph my sine squared. And this is sine squared is a little tricky. I don't know if I've shown you this in the calculator. You have to put the square on the outside of the parentheses like that. So it's going to be sine squared, whoops, times tangent of x. That's one equation. And then I'm going to set that equal to 2 tangent x. 2 tangent x. Press enter. Now I'm going to look for answers here. And we're going to see that the answers we have, let's go menu, analyze graph, intersections of these 2 graphs. You'll see we have an answer here at 0. I'll have another one, hopefully at pi. That would mean I did it right. Analyze graph, intersection. We could see this answer will be at 3.14. And then let me move these equations out of the way. And if I tried one more, analyze graph, intersection, you'll see the next one's at 2 pi. And so every answer comes on a period of 1 pi. And so we did do this correctly. How about that? So with this, you can get started now with your DOL. DOL number 4. All right, so now we're going to look at example 5. It says here to solve our equations for 1 cycle. I want you to make note of this. We want to solve it for 1 cycle and then state the interval for which it's true. And then we're going to check our answers by graphing. Okay, so here we go. This time, tangent's already isolated. I know there's a 2 there. It's actually already isolated. So tell me, on a unit circle perspective, what is tangent? Is it y's? Is it x's? Or is it slope? Slope. We need a slope of square root of 3. Now, a square root of 3 is a positive slope, so it's going to be first and third quadrant. And square root of 3, I think, is approximately like 1.73 or something like that. So I'm going to draw mine like this. I'm just going to guess that that's the slope of square root of 3. Okay, so there's my slope equaling the square root of 3. Now, those are going to be where my answers come from. So now let's go back over and solve. Now, remember what we were just doing previously. Once you isolate the trig function, what do you do next? To get before what was just an x. In this case, the 2x isolated. How could I get my 2x isolated? No, tangent's not adding. It's not dividing. It's not multiplying either. What's tangent doing? Tangent is a function. What's the opposite of a function? Inverse. We're going to do an inverse. So 2x will equal the inverse tangent of square root 3. Now, for the sake of our hand trick, square root of 3 is the same thing as square root of 3 divided by 1. So take the back of your hand. Why am I saying the back of the hand? Inverse. So we're looking at the back of your hand. You need 3 Y fingers, 1 Y finger.
Okay, the ring.
This time we bend our ring finger. Right? Y'all are saying yes, and it's not right. What? I'm not even bending it. I'm like waiting for y'all. Is that my ring finger? What am I bending? Index. You bend your index finger to have 3 Ys, 1 X. Flip it back over. What is your index? Pi over 3. So we're getting that 2x equals pi over 3. Now here, this is pi over 3. What would this one be down here?
4 pi over 3.
Okay, now this is 4 pi over 3 because it's just more than 1 pi. Now it says to find it for 1 cycle. Tangent's different than sine and cosine. What is tangent's period? Just 1 pi. This solution set is not needed. This is the second cycle. So we don't need that solution set. So we only need the answer between 0 and pi. Okay, but this time we have to do something new that we haven't done yet. X still isn't solved for. How could I solve for this x? I divide by 2. Now, when I divide this by 2, I need to divide my interval by 2 as well. So my 0 gets divided by 2. This gets divided by 2. And pi gets divided by 2. That's going to come into play in a second. So what is my solution here? X equals, what's pi divided by 3 divided by 2? The answer is pi over 6 on the interval 0 to no longer to pi. Tangent is normally 1 pi, but this has a different period. This pi, it would not be 0 to pi, it would be 0 to, what do I have written there? Right there. Pi over 2. Now, why did it become pi over 2? And actually with tangent, you need to do a, wait a minute. Is tangent at 0? Yeah, we can do brackets. This would be my solution set right here. I guess technically for tangent, you don't have to include the pi over 2. You could do a parenthesis on that one. I'll go ahead and do that just so I'm mathematically perfect. But I wouldn't be a stickler on this one. You can do a parenthesis because the period, you don't have to include the second. That would be repeating values. So technically, you could do a parenthesis right there. There's normally tangents would be 0 to a pi with a parenthesis on the pi. So that's why I'm putting a parenthesis there. Hey, why did that change? Because we have a horizontal transformation. Do horizontal tell you the truth or do they lie to you? They lie. So all my answers got divided by 2. Did that make sense? All right, let's do another one. What about part B here? What would you do first? Subtract 1. So we have 2 sine of x over 3 equals -1. Now what? Divide by 2. And so sine of x over 3 equals -1/2. Okay, I'm going to pause there. Sine on a unit circle. What variable is sine? The y. So we need a y value at -1/2. -1/2 on the y is about right there. So this will find the 2 solutions. And sine's going to need both of them. Sine's different than tangent. Sine's period is 2 pi. We need both of those solutions. We can do hand trick here. So, oh, I need to go ahead and write out the math. I didn't write out the math, sorry. What's the opposite of a sine?
Inverse.
Sine inverse. So it'll be sine inverse of -1/2. Okay, take the back of your hand. We need 1 Y finger. Which finger do we bend? Ring. Bend your ring finger, flip it back over. What is your ring finger? It's pi over 6. Now, to make it negative for sine to be pi over, will it actually be 1 pi over 6? It would actually be a -pi over 6 because it's right here. But Now that I have that, I'm gonna go ahead and write my two arrows on here. It's a pi over 6. So the way we've been doing this today is using our unit circle. What would this be as a pi over 6 right here? If that's 1 whole pi and this is 0 and this is 2 pi's.
4 over 6.
Not 4 over 6. It's more than 1 whole pi. So it's got to be bigger than 6. It would be 7 pi over 6. And this one's almost 2 pi's. So it'd be 11 pi over 6. Okay. Now that would be those two values. Now, this is not isolated though. So how could I isolate that? Multiply by 3. This negative looks really weird here. Let me fix that. That's negative pi over 6. What I would do is I would multiply everything by 3. So everything would get multiplied by 3. This right here got simplified to that. So x would equal, when I multiply these by 3, I'm going to multiply these values by 3, this value by 3, this value by 3, everything gets multiplied by 3. So what does that mean? My two solutions would be, what's 7 times 3? Actually, I don't even have to do that. What's 3? 3 can go into 6 twice, so it would be 7 pi over 2. My other answer, again, 3 goes into 6 how many times? Twice, so it would be 11 pi over 2. On the interval, starting from 0, what's 3 times 0? 0. And then what's 3 times 2 pi? 6 pi. That would be the interval. Now, I want to show you how, if we graph these, well, kind of running out of time here, but if we graph these, we could see the same thing. And I'm going to graph it on Desmos because I think it's cooler to see. If I showed you these graphs, I'm going to do y equals tangent to x. Remember, this is how I told you earlier to graph this. And then you do y equals the right side. Y equals the square root of 3. If I graph these, you can see the answers are just like we said. What did we say the answer was supposed to be on the first one? Pi over 6. And the interval, this is the period that we got, is supposed to be half a pi, which means if I add half a pi, I would get my next answer. It's going to say 2 pi over 3 because you would add half of 6, which is 3. So 1 plus 3 is 4. 4, 6 reduces to 2/3. You can see we did that one right. You do the same thing here. If I graph the left side of the equation, 2 sine of x divided by 3 plus 1, and I set this equal to 0. Once again, you can see there, haven't even gotten my two equations yet. I gotta zoom out to get my two solutions. My first solution happens at 7 pi over 2. That's 11 pi over 2. Just like I said, how long does it take for a full period? It would be 6 pi, wherever that is, right in here somewhere, around 18. Why would it be around 18? What's pi? 3.14. So that's what you'd be multiplying by. All right. All right, now we're going to take a look at example 6. Specifically in example 6, I kind of gone through and I said, you know, there's going to be some shortcuts you start to take. Now, let's do that here. It says use the unit circle without simplifying, meaning I'm just going to look at this and consider. It says cosine 2x is going to be greater than 0. Well, on a unit circle's perspective, the cosine refers to the x values. So I want to go ahead and write in here. We have a 0, we have 1 pi, and here's 2 pi. And we're looking just on the function's first cycle here, the interval that'll satisfy this inequality. For cosine to be positive, that means we have to be on the right side of the graph. And it has to be greater than 0, meaning I can't be equal to the y-axis. So both of these are open circles, but I can be any of these points in here. I'm going to do a closed circle here just to show you. I can be anywhere on this interval going this way. And so I'm supposed to start at 0 and go that way. And I can do starting from here at 3 pi over 2 going this direction as well, all the way up to 2 pi its first cycle. So we can go these directions. Now remember, this is pi over 2. This is 3 pi over 2. Okay, so if this function only said cosine greater than 0, we would say it's the interval from 0 to pi over 2, including 0, but not including pi over 2, and then from 3 pi over 2 to 2 pi, not including 3 pi over 2, and technically 2 pi would be starting the new cycle, so we wouldn't include that one either. But this is 2x, so if I wanted to isolate this for x, what I would do here is, now that I've gotten that's taken care of the cosine portion, I would need to divide all the values by 2. So everything would get divided by 2 here. Everything would get divided by 2 for this first cycle. And so what does that mean? That means this first interval where it's true is from 0, close circle means a bracket, from 0 to pi over 2 divided by 2, which is pi over 4. That we have a true value. Open circle means parenthesis. And then I'll have a union from 3 pi over 2 divided by 2. That's 3 pi divided by 4 with a parenthesis. All the way to 2 pi. Now 2 pi will still be, 2 pi divided by 2, which is 1 pi. 1 pi will still be a good answer, but it starts the second cycle, so I'm going to do a parenthesis around it. That would be my first cycle right there. That's the first cycle of answers. It's right in there. Whoops, let me try this one more time. First cycle. That would be my first cycle. And I'll show you this graphically. I'm going to use Desmos. I think it's just easier to see this. So we're going to put 2x, y equals cosine of 2x. And then here I already have y equals 0 from earlier. I need to zoom this thing in. So if I zoom in here, I want to know where am I greater than 0. And the other thing that's nice about Desmos is I could type this in one more time and actually type in the equation as they gave it to me. Cosine 2x is greater than 0, and it'll shade in the area. Notice if we're only looking on that first interval between these two, the first cycle, I would have to be looking between this maximum and this maximum, which is between 0 and pi. Like I said, between 0, this reduced to become a pi. So between 0 and pi, the areas would be from 0 all the way to pi over 4. We have a shaded, that's a good part of the answer. And then from 3 pi over 4 to 1 pi, we have a good portion of answers. Now, the easiest way, as just did like a consecutive interval or an interval that's not broken, the easier way of writing this as an interval, a non-broken interval, would be to go from here all the way up. And you could do that by, instead of saying 3 pi over 4, by starting as a negative pi over 2. I could say that's a negative pi over 2 if I went down and then divide that by 2. So let me reduce these so we can see where these values are coming from. This would end up being a negative pi over 4. So if you wanted to have a non-broken interval, you could write your answer as a negative pi over 4. Oh, it needs to be open circle. I mean a parenthesis, since that's an open circle. Negative pi over 4 to positive pi over 4. That would be the best way to write it, as one interval. Okay, so from negative pi over 4 to, let me take off some of those so we're not distracted more, to pi over 4. Notice that would be one consecutive interval that would give the answer. You'd only list, with intervals, you only list the x's. Okay, now we're going to come back to this in a moment. Okay, and now let's try this other one. We want to know where sine of x minus pi over 3 is greater than or equal to sine x. And so sine is dealing with the y's. And I'm going to, because I have two different y's, I'm not going to change my values around here, meaning my pi's, my radians, if I listed these out. But I am going to show you what's a little bit different on this one. And the reason I'm not going to change them out is because I'm working with two different angles at the same time. What I'm going to do is plot two different points. I'm going to plot here. Let's just do this one in green. This one will have a green value. And so let's just say we start with a value of 0. If we plugged in a 0 into x, this would be 0 minus pi over 3, which means we would need to find negative pi over 3, which negative pi over 3 is going to be about right there. Okay, I'm going to start at that point. Now, I will do the sine x value in blue. Now, if x was 0, then sine of 0, that would be this point right here. Now, we want to know when is the green point greater than or equal to the blue? And since we're sine, we're talking about the y's. When is this y value greater than that one? Well, it's not right there. And as you can notice, what's happening is because we're talking about the angles, what that means in trigonometry is you're talking about this radian measurement here. This is a distance here. That's a distance of pi over 3 radians. Pi over 3 radians. That's the distance. That's how many radiuses it would take to go from there to there. So what we want to know is when, as I move along this circle, would I have a value that the green dot is higher than or equal to the blue dot? And so I'm going to try my best to see if this functions right. But if I moved it around, let's say I moved this one, it's not working well, is it? If I move this around, I'm going to try 1 pi over 3. Let's see what we get. If I moved it to 1 pi over 3, this blue dot will be right here. The green dot is right there. So now this is when we're now at 1 pi over 3. Now notice the blue is still taller than the green. That's not good. We want them to be equal. Well, the first time it's going to become equal is when we get to 2 pi over 3. Because at 2 pi over 3, if I split this right here, if I split it, you can notice that the two values would be equal. The blue would equal the green. So this is a starting an interval that's good. This will be a winning interval. So starting from this point, this is the point where it's going to be good. And as we go around, you can see the blue is going to be falling first. So the green will be higher, and it'll be true all the way up until we get to the same idea going on this side when we have the blue over here at this pi over 3 and the green over here at this. This is when they will finally catch up and green will start to trail behind again. Again, these are pi over 3 apart. They're pi over 3 apart. That's pi over 3 radians here. And that's when they're equals again. So all of this interval is good from here all the way up until, from here all the way to that point. They're good. And this will be closed dots because we can be equal to. So starting from here, now this point right there is 2 pi over 3. If I add it in, that is 2 pi over 3. If you did your math, 2 pi over 3 minus 1 pi over 3, that's at pi over 3 there. In case you wanted to know, I'll do a different line for that one. That would be 1 pi over 3 there. And I'll go ahead and put what this one is there. No, I won't. That might get confusing. And I'll do one more here. So the interval works starting here at 2 pi over 3. And it ends working in the pi over 3 that's almost 2 pi, which would be 5 pi over 3. That's when it will no longer satisfy. So it'll go from here to here. This is a good interval. So the interval would be from 2 pi over 3, brackets, because we can be equal to it, all the way to this 5 pi over 3. Now, if you're wondering why did I add this dotted line, just to show you where the green would be, because the green point trails behind by 1 pi over 3. 2 pi over 3 minus 1 pi over 3 is 1 pi over 3. And at this point right there, that point, if you wanted to know, that would be 4 pi over 3. Notice that's where the green dot would be. But the blue, the x itself, is what's setting the interval. That's why I'm going not off the green dot, but off the blue dot. So starting here, they're at the same height, and then green's higher because it's trailing behind it. And then starting here, they're equal again, and then the blue is going to be higher than the green. So that should be my answer. Now let's double check on the graph. We want to know when sine, let's do it first here, it was sine minus pi over 3. And then we're comparing that to sine of x. And we want to know when this is greater than or equal to sine x. And as you can see here, scroll this over a little bit. Here's 2 pi is going to be just over here. We can see that we start from 2 pi over 3 and it ends at 5 pi over 3, just like I said. All right. Now, example 7. Very similar thing here. We're looking at inequalities, but this time I'm gonna have values that are not on the unit circle. So let's work through trying to solve this again. We want to know when 3 cosine x plus 1 is greater than or equal to 0. So let's first subtract 1 here. We're gonna solve this. So this time, instead of only using unit circle, we're gonna have a problem. We cannot use the unit circle here very well. So I'm gonna have 3 cosine x is greater than or equal to -1. And I'm gonna need to divide this by 3. Divide this by 3. And so cosine x is going to be greater than or equal to -1/3. So I want you to think cosine refers to the x. So cosine is the x. -1/3 is over here. Let's just say that's about -1/3. So we'd have two values. And if I wanted to be greater than 1/3, I would need to be on the right side. So cosine's x, my interval is going to be in between these two values here. So anything to the right of these two points. So anything in here is going to be a good interval. So our interval will include anything from here through here. And I can do this as one interval. No, it says 0 to 2 pi. Never mind. So we're going to have to break this and list it as two different intervals. We'll do one where it includes the 0. And we'll have one that comes all the way up. And it's going to stop right here at 2 pi. It's going to stop at 2 pi. So we need to find out what is this point here? What's that point there? So I'm going to get my calculator here. And we're going to do our math. So let's go cosine inverse of, oh, I didn't even write it down here. A -1/3, -1/3. There's our first value that we want. I don't need this anymore. I can delete those. And our second value, notice that this is right here, 1.91. Well, this is the same amount of distance, but it's going down from 2 pi. So I'm going to take 2 pi. A lot of times we might just list it as -1.91, but this has an interval so starting at 0. So I need to do 2 pi minus this 1.91 to see where that starts from. So I'll type that in. 4.37 is going to be our other answer. So let's go ahead and add those in. And to get my math right here, I need to type what I need to write out what I typed in the calculator. I typed in cosine inverse of -1/3, which that was equal to 1.91. 1.91. This value here was 4.37, and we got that by saying 2 pi minus the 1.91. And so now to write out our interval, the good answer, start at 0. There's a closed bracket, go all the way up to 1.91. This we would include because we're greater than or equal to. So I need to include this point here. So closed dot and a closed dot there as well. So I'm going to go back and do a bracket, union, bracket from 4.37 all the way to 2 pi. And you would not include 2 pi because it's a parenthesis there. So there's my answer for the first. And now let's do with an absolute value. What would happen here? Well, the way you go through your algebra is you would add 1 first. So I have 4 times the absolute value of tangent x, which is less than 1. And then I'm going to divide by 4. And so the absolute value of tangent x has to be less than 1/4. So here's how this works with absolute value. What that means is you break this into two separate equations. If you're doing absolute value, remember that just turns anything positive. And so you either have the positive original, the original is positive, is less than 1/4, or this means you could have a negative tangent. But with inequalities, if you add a negative, the inequality flips. So we'd say that negative tangent x is greater than 1/4, which will mean that tangent itself will be less than, when I take that away, than negative 1/4. No, I think I got this backwards when I solved it. This right here, I need to, on the first step, I'm sorry, I would keep this inequality the same, and then it'll flip over here. So tangent is, originally it was less than, so we'd say negative tangent x is less than 1/4, and so when you solve that, it becomes tangent x is greater than negative 1/4. Okay, so now we're gonna go to our calculator, because that is not a hand trick value. We do know tangent is like slope, and so we would have two different lines. I'd have a slope of 1/4. That would be up 1/4, something like this maybe, up 1/4, and then I'd also have a slope of down 1/4, something very similar. That would be my two slopes. So slopes equal plus or minus 1/4 on those lines. So what would those be? Well, let's go to the calculator to find out. All I'm going to do is one calculation here. I'm just going to do x equals tangent inverse of 1/4 to find out what that equals. So we go to our calculator, tangent inverse of 1/4. And I'm getting 0.24497, 0.24. It's going to be 0.24 here. 0.24. And since I'm using a calculator and it's rounding, I should be doing a squiggly here. So this is 0.24. So what would the other answers be? What you're going to have to do is mathematically think about it. That was from 0 going this way, from 0. So this next answer here, I'm going to be going from pi, and I would take away 0.24. This one I would add 2.4, and this one I'm going to go from pi and take away. So my other answers this time around are going to be a little bit trickier to find. Okay, now I got that added in. My other ones, I need to go from pi and take away this tangent inverse value. So starting from pi, I would take away that amount. There's my second answer. And then I would go from here, this value pi, and I'm going to add in that tangent inverse. And then finally, I'm going to go from 2 pi. Oops, forgot to put the 2. And I'm going to take away that inverse. Minus, I need to put the minus on there. Minus, and I'm going to take away this inverse. Okay, so these are my values that I want to make sure that we incorporate into our values here. So now let me fill these in. This value is 0.2, looks like it's going to be 290, 290, 290. This value down here is 3.39, 3.39, 3.39. And then finally 6.04. 6.04 represents that value. Now, going back to the very original, we wanted the tangent to be less than 0. Which I told you that means that the positive tangent needs to be less than 1/4, and we also need the tangent to be greater than negative 1/4, which means on this first line with the positive slope, I need to be less than it. So we're looking over here, and this one's tricky because we're actually talking about the angle. We'd go this way, and this one was saying be greater than the negative 1/4, and so to be greater than the angle would be going this way, and over here it would be going up. So my intervals that are good would be starting here, going up, and we do not include, so I'd have an open circle. I would start here closed, and I would go to this one, closed, and then start here closed, and I would approach 2 pi, but I'm not going to include 2 pi. So here's what my inequality would look like. This interval would be from 0 to, I did close circles, goodness. All of them need to be open. Let me try this again. I can't believe I just did that. Needs to be an open, and that needs to be an open. Okay. The only one that should be closed is the 0 because you're starting there and that's in between the interval. All the rest should be open. So from 0 to 0.24 union, from 2.90 to 3.39. And I'll move this over slightly. Union from 6.04 to 2 pi. And again, parenthesis on that, because we're not trying to include 2 pi in there. And so those would be our values there. For example, 7b. By the way, you could check this with the calculator as well if you wanted to. All right, you try DOL number 3. You can use a calculator if you need to, or you can do your algebra. Go for it. DOL number 3. All right, example 8. Applications. When breathing, a normal cycle takes place about every 5 seconds or so. Velocity of airflow is modeled by this equation, where y is measured in liters per second. Velocity of airflow is positive when we inhale and negative when we exhale. Okay, for one cycle of breathing, find the interval of time where 0.6 sine 2 pi over 5x is greater than or equal to 0.3. So this means we're inhaling, because positive means we're inhaling. We're inhaling 0.3. Let me go ahead and mark this. Inhaling. We're inhaling 0.3 liters per second. We want to know we're at least 0.3 liters per second. That's what we're trying to figure out here. And so if I did my math here, I would start, I'm trying to solve for x. I would divide both sides by 0.6. That's what I would do first. As I try to isolate this. And so I have sine of 2 pi divided by 5. X has to be greater than or equal to, that right there is 1/2. Now, since I have the sine function isolated, I could move on and look at the unit circle. So if I drew a unit circle here, let's try to draw as best as possible. Let me use some tools to make sure, get a good looking unit circle. Well, there we go. Crooked unit circle to begin with. Crooked y-axis, I should say. Okay, now let me add a circle on there. Okay, on my unit circle, we need sine to be greater than 1/2. That means I'm looking at the values in here. And specifically sine is y, so I need the values that are greater than 1/2. I need to find from there, open circle and open circle. I'm looking at this interval in here. Okay, now let's use our hand trick. So how I would do this is I would say 2 pi over 5, if I was going to use a calculator, x is going to be greater than or equal to the inverse of sine of 1/2. Now, what is that as a hand trick? Let's see. I'm looking at the back of my hand. To have one sine finger, I need to bend my pi over my ring finger, which when I flip my hand over is pi over 6. This is pi over 6 here. If that's pi over 6, then this value would be a pi over 6. Specifically, it's 5 pi over 6 because it's almost 1 whole pi. So that's 5 pi over 6. So now I want to write that out, that 2 pi over 6, and I got a second bound. What I can now say is that, let me write out my two boundaries. Pi over 6 is less than or equal to, less than or equal to, I should have done closed dots. Here I am again doing open circles. Let me get that right. Pi over 6 is going to be the less than value, less than or equal to 2 pi over 5, which has to be less than or equal to this value over here, less than or equal to 5 pi over 6. And so the way to solve this is I'm going to just do the opposites here. Oh, I forgot the x. Oh my goodness. I'm going to have to erase it to fit that in there. X less than or equal to 5 pi over 6. And so to solve this, I'm just going to do the opposite. I'm going to multiply by the reciprocal on all three of these. So imagine distributing through the reciprocal of 2 pi over 5, which is 5 over 2 pi. And that's what I'm going to multiply here. Here, I'm going to multiply the same thing, 5 over 2 pi. And in the center here as well, 5 over 2 pi. Now, this one, these cancel out. Over here, the pi's cancel out. And over here, the pi's cancel out. And so I now get my interval of breathing. I am good anytime I'm in between. Let's see, this is 5 over 6 times 2 is 12. So from 5/12, which is less than or equal to x, which is less than or equal to 5 times 5 is 25 over 12. So that's my interval that I'm good. And the way I've been writing it earlier today is 5/12 with a bracket, comma, 25 over 12. You could write your answer either way. That's my interval. And that's the interval of time. So explain what this means in context to the scenario. Well, that means from, I'm going to change it to a t because we're talking about time. Well, they gave me an x, so I better stay with x. From x equals 5/12 seconds to x equals 25 over 12 seconds. A person is inhaling, it's a weird word, inhaling at least. That means it could be equal to, it could be more than 0.3 liters per second. Of air. That's what it means in context of the situation. So that would be our answer right there. Now that I worked an application, how about you try an application? Your last DOL of the day, DOL number 4, try working through this application. See what you come up with.